So today, now that you have filled out the unit circle successfully, we are going to look at how to use the ordered pairs from the unit circle to evaluate trig functions. So now that we have filled out all the ordered pairs, let's figure out how to use them. So what I've done is I've grabbed my unit circle that we filled out, and it has all the ordered pairs on it. And I'm going to jump to page 27, and we're going to look at just the sine and cosine ones. So let's get right to it. And I'll number them. I'm going to skip a whole bunch, but it'll be okay. So number 2 on page 27 says cosine of pi over 4. So just one thing about this for a second, okay? Cosine is the x. Oops, hang on, let me erase that real quick. Cosine of any angle's definition is the x over the r. So I'm going to use green. I'm going to go into my unit circle. I'm going to go to my angle, pi over 4, which is this line that I'm drawing in green right here. And because I want to use the x, because cosine is the x, I'm going to grab the x part of the ordered pair. So now I have that cosine of pi over 4, the angle they gave me in the problem, equals root 2 over 2 over some r value. But we're on the unit circle. And on the unit circle, the radius equals 1. So that means cosine of pi over 4 just equals this x value that we had right there, the root 2 over 2. And if you didn't know this definition of that I'm putting an asterisk by right here, let's talk about that really quick. So there's two trig functions we're going to work with today, cosine and sine. And those of you who have taken physics or are taking physics, you will learn this during the school year, that define the x part of a vector, you do the magnitude cosine the angle, and define the y part of a vector, you do the magnitude sine the angle. Cosine, you're used to doing the SOHCAHTOA. And so if I look at this, I'm going to use my green. If I do this right here, this angle in here is my theta. This distance side to side is my x. This is my y, and this is my r. So if you're going to do cosine right here, it's going to be the adjacent over the hypotenuse, which is where this definition comes from. So cosine of theta equals the x, the adjacent, over the hypotenuse, the r. Similarly, sine is going to be the opposite, the y over the r. So sine of some angle is equal to y over r. So we're going to have to memorize these and know these inside out, left and right, up and down. But we're going to keep using these to keep working on page 27 and 28. So let's do some more. So let's try some more. So that was number 2. Let's try number 3 because it's a sine function. Number 3 says sine of pi over 6. Remember, sine is my y over my r. So I'm going to go to pi over 6, which is this one right here. The y value is a half. So it's going to be 1/2, and the radius is 1, so it just equals a half. Let's try number 4. Number 4 says cosine of pi over 2. So I'm going to go up here to pi over 2, up, straight up. The cosine is the x, so I'm going to take the x value, equals 0 over my r value, which is 1. 0 over 1 is 0. So there's that answer. Here's this answer. I'm going to switch colors just so that we can keep everything clear. Number 5 we can't do yet. Let's do number 6. Number 6 says sine of pi over 3. Remember, sine is my y over my r. I'm still going to go to the pi over 3 line, which is right here. Y is my, sine is my y value, sorry. So it's going to be root 3 over 2. Oops, I said the right thing and wrote the wrong thing. Root 3 over 2 over 1, which is just root 3 over 2. Let's see. 7 we can't do yet. 8 we can't do yet. Not 9, 10, 11, 12. Let's try 13. Ooh, 13 is a little tricky. So I'm going to add a new slide for 13. Number 13 we need to do a little bit extra work on. Number 13 says sine of negative 23 pi over 6. I want to look at this theta, this angle, for just a second. It's an improper fraction, and we need to simplify a little bit because we don't have a negative 23 pi over 6. So 6 goes into 23 3 times, or negative 3 times. So 6 times 3 is 18, and then 23 minus 18 means I have a remainder of 5. So I have negative 3 whole pies and negative 5 pi over 6s. So I've converted this improper fraction into a mixed number down here. So that says negative. I have to go down. So I'm going to go negative 1 pi, negative 2 pi, negative 3 pi. I have to go negative 5 pi over 6. So I'm going to change colors for a second. And this is where the bow ties come in handy. This isn't what I call an over 16. The denominator can't change. This right here is my 5 pi over 6 if it was going in this positive direction. But I don't want to go in the positive direction. I want to go in a negative direction. And if you look at the yellow line I'm drawing, when I go in the positive direction, 5 pi over 6 is just short of the pi line. So if I'm going in the negative direction, this is going to be negative 1 pi over 6, 2 pi over 6, negative 3 pi over 6, 4 pi over 6, 5 pi over 6. I'm right here on this line. And it has to be on a line that has a denominator of 6 because they all go together in their little bow tie teams. So this angle, negative 23 pi over 6, is the same thing as pi over 6. They are coterminal. Very important word we learned earlier. So what I'm really looking at is pi over 6. So now if I want to do sine of negative 23 pi over 6, I can say the y value there is a half over the radius, which is 1. So the answer here is just a half. Just a little bit of math to do up front. Let's try 15. 15 is very similar. So number 15 says that I have cosine of 13 pi over 3. So we're going to reduce this again. 3 goes into 13 4 whole times. So I have 4 whole pies with 1 pi over 3 left over. So if I do my 4 whole pies, I'm going to use a color. I'll use my blue over here. So 1 pi, 2 pi, 3 pi. There's my 4 pi, and I have to go 1 more pi over 3. Well, here, right here is my 1 more pi over 3. Cosine is x over r. So I want to grab my x part of my ordered pair. So cosine of 13 pi over 3 is going to be 1/2 over 1, which is just 1/2. Let's try number 17. Number 17 says cosine of negative 7 pi over 4. So instead of going, I'm going to erase my color really quick. Instead of going here, moving up, we have to go backwards. We're going to go by quarters. So 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, negative 7 quarters, negative 7 pi over 4s. Right here, cosine is the x piece. So this is going to equal root 2 over 2 over 1, which is just root 2 over 2. Let's keep going while I add a picture in. Let's see, we left off with number 17. Let's do number 19. 19 says we have sine of 5 pi over 3. So back to an easier question because 5 pi over 3 is on my circle. It's right there. So I went down to this line. Sine is my y over my r. So I'm going to take the y part of the ordered pair. So I'm going to have negative root 3 over 2 all over 1 because my radius is 1. So my answer is just negative root 3 over 2. Let's try 23. 23 says sine of negative 25 pi over 6. So again, we're going to have to clean this up a little bit. 6 goes into 25, 4, so I have negative 4 whole pies, and then I have 1 left over, so negative 1 pi over 6. So I do red for this one, I'll color code with some red. So negative 4 pi, so 1 negative pi, 2 negative pi, 3 negative pi, 4 negative pi, but I still need to go right here, the negative 1 pi over 6, which is equal to 30 degrees, and I need this because of this right here. So I'm going to go down right here to my blue bow tie line. Sine is my y value, so I'm going to have negative 1/2 over 1, so my answer is just negative 1/2. Doing great. Let's see. Insert my picture one more time for you. That was 23. Let's do 26. 26 says that I have cosine of 3 pi over 4, which is on my circle. So 3 pi over 4 is right here. Cosine is the x value. So I'm going to have negative root 2 over 2 all over 1. So just negative root 2 over 2 is your answer. Let's try 28. Cosine of negative 8 pi over 3. So 3 goes into 8 2 times. So I have negative 2 whole pies. And then you have negative 2 pi over 3 left over. So I'll do blue coloring for this one. So here's negative 1 pi, negative 2 pi. Here's 1/3. Here's a pi over 3 team. It says I have to go negative 2 of them. There's the first one. And then there's the second one right there. Cosine is the x part of the ordered pair. So on my x part of my ordered pair, let me just erase a little bit. The x part of my ordered pair, I want this. So negative root 3 over 2 over 1. So just negative root 3 over 2. And that's all the ones we can do on that page. So let's go over. I'm just going to do a couple on the next page. It's the same idea. They're just in degrees. So let's see. Let's do number 1. Sine of 60 degrees. So 60 degrees, sine is the y value. So root 3 over 2 over 1, which is just root 3 over 2. Number 3 is cosine of 0 degrees. So for this one, I'm going to go to 0 degrees right here. Cosine is the x, so grab the x. So equals 1 over the radius, which is 1, so just 1. Number 4, sine of 0 degrees. We're at the same place, but we want the y part, which is going to be 0 over 1, which is just 0. 5 is cosine of 45 degrees. So 45 degrees right here, and take the x part, so root 2 over 2. And so you can see how these keep going. I want to look at, let me see if I can find one really quick. Let's look at number, I'm going to skip all the way to 28, and it'll be the last one I do. 28 says cosine of 900 degrees. Make your life easy, kiddos. Take your 900. I'm going to subtract 2 circles, which is 720 degrees. When you get that, you get 180. Those cancel out. Borrow one with that an 8, 180 degrees. So at 180 degrees right here, to do my cosine, I want my x value. So this would equal negative 1 over 1, or just negative 1. So page 28 is the same. One thing I do want to explain to you is this fact. Because on page 27 and 28 it asks for the exact value, which means you're not touching a calculator. An exact value means I'm leaving my answer as root 3 over 2. I'm not typing this in. No decimal. No decimal. No calculators. So make sure you're leaving your answers in exact form with no rounding at all.